This lesson is about isosceles and equilateral triangles. By the end of the period, students will be able to apply the properties of isosceles and equilateral triangles. Isosceles triangles are common in the real world. You can frequently see them in structures such as bridges and buildings, as well as in art and designs. The congruent sides of an isosceles triangle are called legs. The third side is called the base. The two congruent legs form a vertex angle. The other two are the base angles. So we can look at our example here on the right of our picture that we have. Again, the legs are the two congruent sides. So we're looking here and here. And the base is the third side. The base does not always have to be the bottom, quote unquote. Okay, so I could have an isosceles triangle, drawn like this. And so the base would be this top piece here. Again, we don't really refer to bottom or top here with these. One other side note, in construction, triangles are one of the strongest shapes you can build with because of how they distribute forces. In fact, if you look at bridges, especially if you're looking at like how the support structure is designed, you'll see lots of triangles in whatever shape that the bridge is designed in. Also, you'll see them on roofs. The trusses of a roof. Okay, so triangles are very strong and very useful. So let's talk about base angle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So looking at our picture here, this triangle ABC, I know that there's a tick mark here on AC and CB, those two sides, those two segments. So that means that the angles opposite them are congruent as well. So looking over here at our final conclusion here, angle A and angle B are congruent. All right. Now this works both ways. Okay. So looking at the converse here. All right. If two angles of a triangle are congruent, then the sides opposite them are also congruent. So in my picture here now, if I have a triangle with two angles marked congruent, then the sides opposite them are also congruent. All right. Let's look at how we can find missing angle measures. Now, things to remember. The interior angles of a triangle should add to 180 degrees. So we know that. So we have some limits with what we're working with here. All right. So for part A on here, again, looking at this is an isosceles triangle, which means the base angles are congruent. So if I'm asking you what the measure of angle A is on this, well, the measure of angle A is congruent to the measure of angle C. So the measure of angle A is 70 degrees. Now, if I asked you to find the measure of angle B, you could also find that. I know the question doesn't ask for that. Let me erase this right here. But if I had asked you on here, what's the measure of angle B? Well, again, if A and C are 70, then B has to be what's left over to get 180. So it'd be 40 degrees. For part B on here, again, it asks for measure angle A. We've dealt with arc marks so often in here, we know that the measure of angle A is 53 degrees. Once again, if we wanted to know the measure of angle B, just subtract the 53 twice from 180 to get the measure of angle B for that. If I said what extra information could you mark on your picture, you know that those two segments there would be congruent. For part 2, if we're trying to find what X is here, again, remember, if these two sides are congruent, then the angles opposite them are congruent for 2A. So this is another X. So if you're going to solve this algebraically, it'd be 180 minus 30. Okay, so you'd end up with 150. And there's two X's left over, so 2X equals 150. Again, because they're equal, you're dividing by 2. So X is 75. For part B on here, again, we have in our triangle here, and it's a little hard to see because how it's written, but 42 is this angle at L. But if I have these two sides congruent, then that means that L and M are also congruent. Okay, so on here, I know that we have those two angles congruent. We have these angles here where the x is congruent. Actually, I'll do a double on both of these here. So we actually could prove these two triangles congruent by angle side angle. All right, we know this is 42 degrees here. All right, so you can calculate, I mean, you can do a lot with this. You really can. But I think the easiest way to do this question is find the measure of angle L and M, the entire thing here, and then divide it by 2. So you take 180 minus 42, because I'm looking at this entire triangle here, okay? And then I take that result and I divide it by 2. So 180 minus 42 divided by 2, I get x to be 48 degrees. All right, theorem 4.5. If a line bisects the vertex angle of an isosceles triangle, then it's also a perpendicular bisector of the base. So let's just unpack this for a second. So bisect means cut in half. Okay, so if a line cuts the vertex angle. Now remember, we have base angles and vertex angles. Base angles in an isosceles triangle are the angles that are congruent. So in my picture right now, if we're looking at this example right here, A and B, angle A and angle B, are base angles. So the vertex angle is angle C. So if I had a line that cuts angle C in half, so you can see the little tiny arc marks there and there. Okay, you see them there. Okay, so if I have a line or a segment or whatever that cuts that in half, then it also is a perpendicular bisector of the base. Now, perpendicular means it hits at a right angle. And then again, we have bisector again. So that means it actually makes these segments AD and DB, here, we'll do a double, they're congruent. So because we have a single tick mark on the legs, we can put a double tick mark there. And then it's perpendicular, so that's a right angle there. These are right triangles in there. All right. So that's what this is saying. All right. And then theorem 4.3, the corollary to theorem 4.3. So what it says is this, okay? If a triangle is equilateral, then it's equiangular. So if I have a triangle and all the sides are equal, all the angles are equal, which just kind of makes sense when we talked about an isosceles triangle, how the base angles are congruent. Well, it makes sense then if instead of being isosceles, but all the sides are equal, so it's equilateral, then all the angles are also equal. Now this works both ways, so just so you're aware, it's like saying, hey, these are both true. If I have all the angles equal, then all the sides are equal. If I have all the sides equal, then all the angles are equal. That's all this is saying here. So there's a couple different ways we can do this. We can use exterior angles theorem, which tells us that x and y should sum to 115. That doesn't help you immediately, but you can do it that way. Once you solve for x, you can find out the y using that. But we're going to go ahead instead and stick with the fact that we know that the 115 and this unknown angle here are linear pair, so they're supplementary. So 180 minus 115, we find out that this angle right here is 65 degrees. So I'm going to write 65 here. We also know that x and the 65 are congruent because they are base angles. So the x is 65 degrees. And then we know that the y, the x, and the 65 should add to 180. So 180 minus those other two gives you y to be 50. The second question, it's very similar. We know that these two angles here are linear pair. So we get that this angle is 45 degrees, which means that's what x is. So then y has to then be 90. Last one on here. Again, just to throw a little curveball at you, give you some expressions. Again, what you should notice, and we haven't had this case yet, that all these sides are equal, which means all these angles are equal. Okay, now, again, once you're thinking about this, you're probably wondering, well, how does that help me? You know, I got y minus 10 equals x plus 5. Like that doesn't really help you because you have one equation with two variables. But what does help us is the fact that a triangle adds to 180 degrees. And if all of these angles around it are congruent, then they're all 60. They're all 60. They're all 60. So to solve this, you're just going to take y minus 10 equals 60 and x plus 5 equals 60. And then you're just going to solve for each x and y. So you get x to be 55 and y to be 70. So why don't you take a moment to try to do these three questions, please? Go ahead and pause your video now. I'm going to give you the answers really quick. So for number 4, again, it's equilateral, so it's equal angular. So all of the angles, interior angles, are going to be 60. So you just take 3y equals 60 and 2x equals 60 and solve for each of those. For number 5, you would find the x first. And again, the 110 and the x are a linear pair. So 180 minus 110. And then you can figure out what y is because you know that we have a triangle there. One angle's 90. And you know what x is. So you just take 180 minus 90 minus x, and that gives you your y value. Okay, 20. And then my last one on here, these are two isosceles triangles together. So we know, and they're also right triangles, again. So because of that, then these two angles here where the y is are going to be congruent. And then also, you know, at the x and over here are going to be congruent. And so they all have to be 45 degrees because, again, they're congruent. So if we're just looking at the triangle with the y, the two angles are congruent and they add to 180. So I mean, you literally could do y plus, y plus y plus 90 equals 180 and just calculate the y that way. Same concept. Again, and you can use, your triangle congruence theorems if you want for this. We know that they share that side there, which means these opposite angles are both right angles. I mean, it's kind of obvious what's going on here. And so you solve x the same way. You get x and y to be 45. Okay, obviously you don't have a partner, so you're going to just work on these on your own. So take a moment, go through, think about what we know about base angles in the isosceles triangle. Think about what we know about the interior angles of a triangle adding up to, and use those concepts to help solve these. And then go ahead and pause the video because I'll show you the answers here shortly. Okay, so on number 7, okay, again, we know if we have our triangle ADC, this one right here, and then I have these isosceles triangle, these sides congruent, then both these angles here at the base angles are 45. We know that the 45 and angle ACB are going to equal 180, so it has to be 135 degrees because they're a linear pair. On number 8 on here, again, we know that the interior angles are going to add to 180. So we have a right angle here because they're a linear pair. We have angle A is 70. That makes this angle up here 20. Now, again, we know these two triangles are congruent because we can use, it's a right triangle, so we could use angle, side. I mean, they share that side BD. Lots of different reasons. So angle DBC, this angle right here, is going to be congruent to angle DBA. All right, so that's going to be 20 degrees there. Number 9 up here, again, if angle D is 55, angle E is also 55, which means this angle DCE is 70. Using vertical angles theorem, the angle ACB, I'm making it really sloppy right now, is also 70, which then forces both angle A and angle B up there at the top, okay, to both be 55 degrees. So angle ABC is 55 degrees. This is your last slide of work. Some of they're getting a little more complicated as we go. Do your best. I'll give you the answers shortly. Again, think about what we know. Think about what we know. Do your best. Okay. So what I would suggest is if you have two triangles overlapping each other like in 12, you draw them outside like I did. So I kind of pulled them apart. If I know that this top angle right here is 60 on this, and these two sides are equal, then the angles opposite them have to be equal, and they're going to add to 120, so they're all 60. So I know that this entire angle from N all the way to M right there, that whole angle there is 60 degrees. So that helps kind of fuel my answers for that. Okay, so that's what that told us. Now we look at this right triangle here. So the right triangle with the 45. So we're going to go down here and look at this. Now again, we know that these two sides are congruent, two legs actually, using correct vocabulary, are congruent, which means that they're both 45, which means if M is 45, then N has to be whatever's left over, and that's 15. And because that entire angle was 60 there. So M is 45 and N is 15. Number 3. Again, we know that both these bottom angles are 68 because it's an isosceles triangle, which makes this bottom part of this vertical angle here 44 degrees, which means M is 44. And then it forces N to be 68 as well, because we knew both of these angles were the same because they told us they're both N. 14 is the hardest by far. You have to start with this triangle right here, and the fact that you know that this bottom right angle here is a right angle. If this is 15 degrees, then that angle is 75. That was weird. I don't know what just happened there. And then this angle is also 75 here, which forces this angle to be 30. Okay, now, if this angle is 15, then both of these angles over here have to be 82.5, because if I look at this really tiny slice here, triangle, all three of these should add to 180. And if this is 15, then this left over divided by 2 will give you both those angles there. I know that all three of these angles from here all the way to here are going to add to 180. So I'm going to erase some of this madness on here so it's not so crazy looking for you. Still kind of crazy looking. So we know that this angle right here, this tiny little angle right here, is 82.5. We know that this angle right here is 30. And so this angle at M is got to be 67.5 because all three need to add to 180. So again, once again, we have a triangle with an isosceles triangle with two congruent pieces, legs here, which means the base angles N and this unknown here are the same. So you take 180 minus 67.5, divide by 2, and that's how you get what N is.